Hey everyone.
Hello.
I'm Ian Shadden. I'm one of the training content creators here at Epic, and I have with me Mieszko, who I apparently
Close enough.
Close enough. All right, our lead AI programmer, and we're going to be talking about some more advanced AI topics. Last week, I went through a very simple waypoint system. Mieszko is is. I'm slaughtering his name.
No, this is no problem. Seriously,
Just roll with it.
yeah. Let's
Just roll with it.
continue.
All right. He's just disapproving dad every time I say it, right? So we're going to be going over, since we have him in town, he's normally out in Poland, yeah?
Warsaw. Yeah.
Warsaw?
Warsaw, Poland.
We're actually going to kind of kick this up a notch, and we're going to combine behavior trees, perception system, and EQS into essentially creating an AI that hides. And I'm operating the keys, but I'm counting on you to make sure I'm on track,
Yes.
because I'm sure I will do everything absolutely terribly wrong. So I'm going to start off, and I have an AI character already set up. All I've done for him is I have the runner AI, which is my controller, down here in the content browser set up. He was a copy from the player character, so I deleted all of his controls, so he has no input. And I have the runner AI, which is currently just waiting for a behavior tree to run. But besides that, there's no additional setup that we haven't done that we didn't do last time. Okay, so where do we want to start?
So maybe we should start with setting up perception,
Okay.
which you start by adding a AI perception component to your AI controller.
To a controller.
Yes,
Okay.
because it's talking to the controller.
So AI perception.
Yeah.
All right, there we go.
And now we can, we can add specify senses we want your AI to use. So there's this, senses config.
All right.
Add
so-
one entry here.
And that's still around. Okay.
Okay. And from the drop down, pick a class of the
Oh, okay.
sense you want to use here.
So we're doing a hider. So sight first, I guess.
Yeah.
All right.
Yeah, I think we will be able to pull this off without any other senses.
Yeah, we don't want.
So you can now specify properties of the. Just
yeah, I see the little down arrow.
yeah, unfold it.
Oh, geez. More down arrows. Gotcha.
Yeah, and there's sight radius and the sight losing radius, which are different, which makes sense, right? If you see something, then you like pay attention to it, and then just lose the sight of it a little bit further than when you would normally observe the thing.
Yep.
And obviously the cone of vision, so the peripheral vision angle, everything above the 90 degrees to left or right will not get noticed. So you can, depending on your game.
Okay. So this is the start of the peripheral vision.
Yes.
Not I have 90 degrees of delayed view off here.
It's not 90 degrees total. It's
Okay.
just
Gotcha. Cool. And then.
And you might wanna. There's a thing. That's the thing that still doesn't have a blueprint interface. The specifying the team interfaces and stuff like that.
Mhm.
So that it's better. You're better off selecting both, like in neutrals and friends here.
Okay.
That's an annoying bug.
Yeah. Just so you all know, we are actually right on 4.8 preview 2.
Yeah.
So
It's
this is
super hot.
This is super hot and something you guys all have access to.
You can experience the bug for yourself.
That's right. Come enjoy with us. All right. Do anything else? I mean, we have sight radius is probably pretty good for the size of our map. Loose sight, really good. 90 degree
we will be
cone.
able to visualize those things. So
Oh,
we're
God.
fine.
Okay.
We're fine.
All right. Well, that's there. I'm going to compile and save. What next?
So we could even debug if it's all being set up, if it's set up properly. So the way I would do it is I would use a simulation mode, because that's what I'm using for testing AI. So go to simulation. Simulate. Yeah.
There we go.
So obviously you don't see much now, but try enabling, go to show flags,
Show.
developer, and there's AI debug.
All
So
right.
you can already see some things. By default, the perception debug is not being drawn, so we need to go to you probably should close the simulation, like end the simulation.
Okay.
Go to edit, projects. No, that's editor settings.
Editors. Okay.
And there should be gameplay debugger here.
Yeah. Okay. There we go.
Yeah, and like perception. Basically.
Oh, nice. Okay.
Yeah, you can enable behavior trees that will be useful as well.
Okay.
So it will print that debug information about the behavior tree, where AI is like the behavior tree stack, basically.
Since we're going to be using EQS, should we just enable EQS while we're in here?
We could.
Okay.
Yes, do that.
Okay.
Although those things can be changed if you're actually playing the game. You can also see that debug drawing with a special tool, and you can just modify those properties straight from the game without messing with them.
Gotcha.
So you can already.
Ooh. Our dude can see really far.
Yeah. So for example, you instantly see you might use a smaller radius. For
Yeah.
example.
Let's go ahead and stop that. Go to our area perception, and I'm going to drop it down to 1,000, and then 1,500. I like that little gap there at the end. This might be too tight, but the map is really small.
Yeah, you need this guy to be
There we
like
go.
selected.
Yep.
So you can see already it's just noticing the player
Yep.
for some strange reason, because
It's also noticing. I think what is that?
that's a good question. That might be like a spectator pawn that's being created in the simulation mode.
Oh, okay.
So that's the perception. So now we need to create Blackboard and the behavior tree
All right.
to
So
drive the basic behavior of AI.
miscellaneous Blackboard, and this will be our runner Blackboard. I can type. Crack that open, and
So let's add some keys,
okay.
like enemy key or player.
Should it be an object? I guess?
Object?
Yeah. Okay.
Yeah, object. Yeah.
I'll call it player.
Yeah, and the Boolean key visible, like is player visible or something.
Okay. And then,
And that's
well,
do we need them?
we need to hide somewhere.
yeah,
So we'll need a vector at least, yeah.
yeah, like a hiding spot, like hiding
Yeah.
location, something like that.
All right. So there's that, and then
No parent.
no parent,
Yeah.
and so
That,
now
that should be it.
we have our Blackboard. So now we can go ahead and create our behavior tree. I'm gonna save real quick. Always save. And
Be safe, kids.
Yeah, be safe, kids. Always save.
Always safe.
G.I. Joe. Okay. Runner.
What?
Behavior tree. And go ahead and crack that. And then we already have a runner Blackboard.
Yeah, that's
Great.
we have only one Blackboard in
We
the
only
project, so the root node is picking it up. One thing that some people get confused about is the root node. You see like this one thing, and you see in the editor. That's the editor only thing. It's not really a node. And if we're replying to your questions or like describe ways of doing things in behavior trees, and we are talking about the root node, we usually mean the first composite of the behavior tree. So the thing you plug here as the first node, because that's the actual root node of the tree. So it requires some UX tweaking. We
All
need
right,
to
I get to
do
go
something
update the
like-
docs because I did not know that.
Okay.
All right.
Sorry about that.
It's all good.
That's why I
That's
tend.
great to know.
So we need a selector here.
We need a selector? All
Yeah,
right.
that's most of the use cases of the behavior tree. The first node, the first composite node is a selector,
Right. Making.
and
yeah.
and I tend to name it root. You don't have to do that, but you'll see once we show the debug drawing for behavior tree and like other things, you'll see this name. Well, you should.
Okay.
See
yeah.
this name, which makes
But you won't
sense,
see.
right?
But you won't see this name.
Yeah, this
because-
is just for in like for editing the behavior tree,
All right.
so that you get a means of specifying the other assets like behavior tree, like
Well,
Blackboard.
Gotcha. Well, I'm going to name it the real root, so there's not a.
Okay.
There's at least a name differentiation here for anybody jumping in the middle here.
Fair enough.
Okay. So
So what kind of logic do we want?
we need to know that we need to be able to say, hey, we've seen the player, and then we need to find a hiding spot, and then we need to move to that hiding spot. Yeah.
Mhm.
So we need at least at first to say, oh, I need to know how to behave right when I see the player, or at least I need that event. to kick this all off.
Okay, so pro tip, first of all, you need a fallback behavior.
Oh,
Because like if you run simulation, there might be no player. If you run like a game that you can observe AI from afar, they won't see you, but they need something to do, right? So if you don't supply a fallback behavior, like the super basic way of doing that is just put a wait there, like 5 second, 1 second wait, and if you don't have that and you only have things that depend on player being there, the AI will just every frame it will rerun the tree because it wasn't able to find a valid behavior.
So it gets really spammy.
Yeah, that's basically one of the ways to kill your performance.
Yeah.
But that should be the last node of the tree because that's like the last resort.
Okay.
So now we need a selector that will have 2 tasks. The first one, find me a spot to go to, and the other one, go there, basically.
So we need a run EQS query.
Yep.
And that'll be our find hiding spot.
Hiding hole.
Yep. And then we need.
And then you need to specify where the result of the query will be put.
Yep. It's currently set to.
Okay, so because it's filtering the behavior, the Blackboard entries you have by type, and it's showing only the vector and actor.
Yeah, because we're
keys
looking
here, and we have only one valid key in this regard. So
exactly.
It's just showing.
But if we had more, then we'd need to go down and be oh, nope, hiding spot.
It's just, by default, it's just selecting the very first one you have.
Right. And then we need a move to, and again, it's automatically selecting our hiding spot. And I'm going to call this move to hiding spot. All right. So we have all this ready at this point, but it seems to me that this is just simply going to execute.
Always hide.
Yeah, he's always going to hide, and we don't really know what we're hiding from yet.
Yeah.
So we need
some perception.
Yes, we need some perception going on.
So there's 2 things you need to do. First of all, like the easier part is you just here add a decorator on the selector that has the find and go to tasks. Add a Blackboard-based decorator.
Okay.
And all we need to do is we just need to change the keys so that we're checking if the player is visible.
Okay. So yeah, and saying as it was the first one on the list.
No,
we want is player.
Yeah, we
visible.
want to check the
okay, so we're
Boolean
going to be setting that key from the outside through perception.
Yeah.
And then it will hammer on this, and then it'll fail, and then move to our wait until such time as the player is visible set, and then we'll move. Gotcha.
Yeah.
Rock on.
So that's the basic setup. Now we need to set the Blackboard key proper value. So we need to tie it to perception system.
Okay. So
how do we do that?
How do we do this?
Yeah. So in your AI controller,
runner AI.
If you select the perception component on the left,
okay,
you will be able to put a function now, an event actually. In the event graph, just right-click in the event graph. Okay. There's.
I mean, we got to. Is this the one on perception?
Yeah. I didn't notice that. That's awesome. So yeah, that's it. And this is actually the basic AI perception notify. It just gives you a list of actors that have been updated in any way. And then you need to query your perception component about every actor to get specific information. And this is on my list of things to improve.
And this.
So you basically, do for each. In our specific case, we will have only one actor, but
we don't know. Well, we need to make sure that we're hitting them all. And this is just returning a list of actors. So we could just simply do like a cast 2.
Well, it should be. Maybe I changed it recently and I don't remember. Can you mouse over the updated actors and you see the type?
Yeah, just actors.
Array of actors.
So we can use a cast 2 node to do a whole branch. Like we're only looking for the player, right?
You could, yeah. You could just skip everything that's not player here.
Or
you could.
I mean,
or if you're making a game that
multiple,
which is my favorite, doesn't care if like a given pawn is a player or not. You just which means if you build your game around like without player concept in mind. If you just treat everything uniformly, excuse me, you then are able to test really a lot of stuff in pure simulation mode, which means you can just use the editor tools to move things around, like fake situations, stuff like that, instead of just having to run there as a player while playing.
Right.
But let's focus on the simple case, which is we have just this one player.
I mean, if there's a
Well,
if there's a better way to do it, we should do it that way.
Well, that would, because like so the very first thing, if we wanted to do that you did wrong, is you named your keys player, right? It should be just enemy. That's why I said enemy.
All right.
But
I mean,
well, we can do that if you
that's
want.
totally changeable.
Okay.
I mean, bam, done.
Yes, it's changeable. And change the is player visible as well.
Yep.
Please.
Is enemy. Yep. Gotcha. We on learning resources team, we like to say words mean things. So use the appropriate word. So
Yeah.
save that, and now we're back to our AI. So should we?
So we don't need casting here.
Okay.
Well, not yet, anyway.
Okay.
Because we. So if we assume we may have more than one enemy, this is also the place we can try decide whether, like which one is the enemy based on like a new perception stimuli. We could do that.
Let's do it.
Because okay, so one thing now we're still missing is we don't know who's our enemy. We're talking about detecting, like checking the perception, reacting to perception, but we don't have enemy at all yet.
Exactly. So I mean, we can.
So there's a couple of ways to do that. First of all, if you detect perception, like get perception information about a actor, and you don't have an enemy, maybe you just should consider this as a new enemy. And whenever in future you get new perception, you need to check whether it's perception about your enemy, and if so, then update other Blackboard entries.
Right.
And if not, then because maybe this is a better enemy now, which is like gets complex, right? So so let's first do a proof of concept.
Okay.
So when games, like a quick dirty POC, what I would do is when AI starts the game, so begin play, add after delay of a second, after running the tree. That's better.
And one, let me actually go ahead and activate that.
Yeah, awesome.
And
Well, tell people what you did. They might have missed
Oh,
it. It was just
sorry.
one silent click.
yes, one silent click. So on my run behavior tree node, I went ahead and I assigned the behavior tree asset to our runner behavior tree. So now when he begins play, it'll kick off. Then we're going to hit into a delay for 1 second. And after our delay,
We can just find the player pawn and set it as the enemy in the AI's Blackboard.
all right.
So get player pawn.
Yeah, does that work from here?
Well, maybe not.
No, so you
No,
get my player index. Since
No,
we're in another controller.
but it doesn't work because you drag the pin out from the delay. If you just right click, it should work. Don't ask me why.
It's context sensitivity. Yep, there it is. Get player pawn.
Yeah, and just
And then from here, we'll store this, yeah?
so we're not storing it in a value. We just want to store it in the behavior tree.
Oh,
entry.
you just want to directly dump
Well,
it
if you want, you could. Maybe that's actually a good idea to have a internal variable, so that whenever you know what, ideally, the ideal way of doing that would be to create a function called setEnemy, and it would all make sure the enemy variable and the enemy information in the Blackboard is consistent always, and you just always use the setEnemy function. So
Okay.
go ahead.
Let's do it. And we need an input that is of a type actor. And we'll call it enemy. Compile that out real quick. And from here,
I would call it new enemy to avoid
okay,
like naming.
new enemy.
Yeah. So first of all, check if it's different than the old enemy.
So equal.
I know. You know. I've seen your blueprints. You do crazy stuff.
You do crazy wrong stuff, but that's what I heard anyway.
It's crazy wrong. No, it's actually impressive.
Branch.
Like pathfinding in pure blueprints.
Yeah, doing a
Mind
star
blown.
in blueprint. Yeah, that was fun. fun. All right, so we're testing to see if it is, if we are, or should we do not equal?
I would do not
Not equal because
but
it looks better at
Yeah.
the end of the day.
like it tells you what's the intent here. Like
Yep.
you care about different.
So,
So
if
when
it's
it's-
not equal, what do we want to do then?
Well, we set the variable and we set information in the Blackboard.
It's become a force of habit now. Use all the reroute nodes. Oh, why didn't I like that? Pawn reference not compatible with actor reference. Is this a pawn? Yes, it is. We don't want a pawn. We want actor. Pretty sure I set that as actor, but yeah, that's fine. Change variable type. Search incomplete. That's fine. Don't worry about indexing. And we'll set that. There we go.
Now we need to get.
We need our Blackboard.
Wait. Try. There might be a function available. Set Blackboard value as.
Set Blackboard. Ooh, members in Blackboard key selector. That's not what we're looking for.
That's interesting. Okay, so grab AI's Blackboard component. So that would be find Blackboard component, find component by class, or get Blackboard. That's
Yeah.
the function available in AI controller, which
yeah.
I should remember because I've added it.
So, and then we can
yeah,
do
and-
off of this. We can
yeah.
set
Value as object.
and then we'll wire that up. We'll wire that up, and then we'll need a key name.
Mhm.
Now, I've been meaning to ask you, is there a reason why you don't allow literals for key name there?
Not really. This is a part of interface that has not been really like worked on yet that much. I mean, it works and it's functional, but there's a lot of things you could do to make stuff easier to use. That's one of the things.
Gotcha.
Especially that you have like two different functions family. One is available directly on the component, which allows you to put a name in. And the other family is in behavior tree nodes, which just requires you to give you a key selector, which is a different beast. And those
Right.
two things are not exchangeable, really.
Gotcha. So while he was talking, all I did was I promoted a key name variable. I named it Blackboard key enemy and compiled, set its default value to enemy. So that way over here in our Blackboard, enemy will be set whenever this is run. And this is being really
And
kind
you
of
did all
funny.
that while pretending to listen to me. Amazing.
Actually, I heard you. There's good
well,
reasons in it.
hearing and listening. That's
Yeah, they're two different things, right? All right, so
Yeah.
we have this little bit set.
Yeah, awesome. So let's get back to the event graph and use this function to set player as enemy.
Set enemy, drag out, completed, and our new enemy. There we go. So now we will have our new enemy set, our Blackboard will be set. This will happen at 1 second after start, so what should happen is he should just immediately start running. Well, let me rephrase. He's not going to
No.
run anywhere because he's got nowhere to go.
Yeah, there's no
we
EQ
haven't
screen.
done the EQS, so the EQS will return false.
Yeah, but you know what? Save everything
Okay, done.
and run the game. And we can use the regular mode.
Oh, okay.
Wait. You're too fast.
I'm sorry.
Wait, okay, so there's, it's not really visible, but at the center of the screen, at the top, there's a snapshot of Blackboard.
Right,
So you can
right
see
here.
enemy is set. That's like I
spectator
suspected,
pawn.
that's the spectator pawn. That's the thing
Yep.
at the center that AI is seeing as well.
Yep.
Awesome.
Well, that's
Okay, so-
it's good to know. It'll that's fine for what we're doing because that just means he's going to be running from that rather than the player.
Yep.
But whatever, it works for our testing purposes. But if we were to go into play, there'd be no spectator pawn.
Yeah.
Yeah. No, that should.
Wait,
should
we can just check it. Just
Yeah.
play the regular. Yeah, and now look at the AI and press the
Was it?
the apostrophe key.
What you looking? What's the command?
Apostrophe key. Not this one, the other one. The other one.
This
It's like yeah, there's like two.
Oh.
Ha! So it
Right.
you didn't know that.
I did not know that.
So
That's
I
awesome.
was actually planning to do a video on using our AI debugging tools. So that's basically one of them. So you can see the perception not updating because you're outside of the cone of view. It's like that green line, and the thing that wait, don't get closer to that yellow green ball. You can see there's close, not past it. You can see it.
The
First
little,
of
the
all,
little
yeah. First of all, it's stopped on the. It's stopped on the border of AI's vision.
It just looks
That's
like
the last location where AI saw you.
right.
I
It
can
just looks like it's a little further beyond because my
no
center.
yeah. It just
It's just a perception.
Yeah,
It's just
yeah.
the way that it's rendered.
So one thing you can see that there are numbers next to the ball. The
Yeah.
first one is strength, which for a by default is for sight is just one because you've seen them or not. But you can also that's you need the C++ access. But you can use that to give AI a sense of kinda seeing. So I did see him, but the strength is 50%. So it's not like AI is not. It's not 100% certainty you did see him. And the other number is age, which should be increasing with time. It's a bug I've already fixed, so 4.8 preview build 3 will have that working. So you will be also able to find out what was the last time you've seen like this given actor.
Gotcha.
And it works for all senses. So if you had hearing, you would get that as well,
Yeah,
like the age and strength.
Like maybe over here there would be another ball that would be hearing, strength 0.5,
Yeah.
age
One
15.
other thing you might have noticed is you just run out of vision, but you run out of only like the ball stops on the second range, which is the sight losing radius, but AI regains the sight contact only when you get inside the green one.
Right, so we can be like, haha, can't see me.
Yeah.
And I can
It's
get
not like
closer
that.
and stab you.
And you can see like all the cool debugging information you have on the left and in the center. That's Blackboard. On the left is behavior tree, and you can see the real root.
Yep.
And the task is basically a stack of tasks or task nodes.
Yeah, we actually get to see the time remaining on the wait node as it ticks down over and over
Yep.
again because everything else is failing out.
Yep.
And yeah, that's
Super cool, isn't it?
yeah, no, it really
Yeah.
is.
Awesome. Okay,
This
so
is
now
super useful.
That's why I wanted to record that video on AI debugging tools. And we didn't use log visualizer yet, which is yet another tool. If we have any issues later on, then it's probably a tool we'll
probably all right.
start using. So we need a EQS query now.
Okay,
Yes.
let's go ahead and wrong key, escape.
Yep.
Let's get in here and miscellaneous environmental query, and we're going to call this find hiding spot.
So before we okay, so how basic should we go? If people know about EQS at all, it's basically a spatial reasoning system which allows you to ask smart queries about environment, like find me all locations based on like specified grid within the specified range, and then score the points so that the points further away are have higher score. For example, that's a very simple query we could do.
Does the simulate mode show the EQS on this guy as well? If it's running, will it pop in?
It might.
Or do we?
Let's give it a try.
Or should we create an EQS pawn to?
So I was so I thought we should use the EQS pawn
Okay.
just to show it off.
Yep.
Because that's actually like it's a fake pawn we can use in the pure editor mode to draw queries
Exactly.
while working on them,
Right.
which is very useful.
So I'm just going to create a new blueprint class, and in our all classes we can do a search for EQS. EQS testing pawn will show up. We're going to go ahead and create one of those, and I'm going to name this. I'm just going to name it EQS testing pawn. I'm not going to be.
2. It's my EQS testing pawn.
There we go. And all you have to do is place him in the world. I have a tendency to try to level them out. It seems to help out a lot.
So
And
let me explain one thing. You need to like create your own project specific blueprint class. It can be C++ as well. That derives from the generic EQS testing pawn, because we had to make the EQS testing pawn abstract so that it doesn't show up in all other places where you pick like a pawn for player, for example, because it's not a valid pawn for other purposes. It's just for EQS testing,
Gotcha.
debugging. So you need to create your own class derived from it, but there's nothing else you need to do with this class. It's all full featured.
Cool. Well, I know there have been issues in the past. If I attempt to set the query template right now, I know there's maybe not the most stable because there's nothing in it.
The query is invalid.
So
currently.
let's go ahead and create something valid. So how do we want to search? I found.
Okay. So first of all, how would you describe the locations, like the kind of locations? Where are the locations you'd like to go to?
I would like to be out of line of sight as far away as possible from the player.
Okay.
But I'd also like to be close to cover. I'd like to be close to a wall. So if we were to look at the map, right? Like if this is the player we're talking about, I would like to be against this wall here because he can't see there. And I'd like to be able to hug against this wall. Now, furthest away, maybe not accurate, right? I'd much rather be not aligned with the player as the way he's facing. If I could, I'd like to be off to his sides, maybe not behind because that means I have to run through him to get there. So I'd want to be like, here, if I were to rotate him just a bit, you know, I wouldn't want to be over here. I would want to be more over here. Okay. Whereas if he was rotated like this, I'd want to be more over here than over here.
Okay, so there's like potentially a lot of locations to check first. So it sounds like the generic pathing grid or grid generator is the way to start. It basically generates points to test on a specified grid.
Right. And so we know our vision radius is about 1500, which gives us, you know, I want to actually just simulate.
So you could just put anywhere, anything there, and just use EQS testing pawn, for visualizing. Okay.
Then
the numbers.
I'm actually gonna boost this to about 2 grand.
Especially that
15.
There might be a bug that the one of the values here, like the range, might be. I think one of the generators has a bug that you put a range in, and it's actually using twice the range. So it says the radius, but it's using it as a.
Is it like donut? I think I ran into that with donut.
Yeah.
Because it was.
Yeah, it's filed. It's on the list of fix.
Okay. Okay, so we'll save that real quick. Now we'll actually have a grid, and so somewhere out here is.
No, you don't need to be in a simulation mode.
Oh, no, I'm not in simulation mode. No, I am in simulation mode. That, my bad. All right.
Yeah, now, select the query here.
Yep. And all the spheres. All right, so my grid's maybe a little large.
So one thing to keep in mind that can hit your performance is like you really need to be reasonable about the amount of points you're testing. It still would be fine because we will be throwing out, like filtering out points really quickly and with cheap tests, but still be reasonable because the more you have, the more work EQS needs to be done, and most of the time you don't need those points unless you like really do.
Yeah, if you need them, you need them.
Yeah, but only then you need them, right?
Yeah. See, then we run into, you know, it's all about, you know, how far do you really need to go? And this situation is a little.
So one thing that's my like little feature you can move it.
Yeah, I'm just gonna move them up so that way testing's okay.
But the feature I love, because it's like showing EQS really nicely, is one of the options of the like properties of EQS testing pawn is rerun query only when move is finished or something like that. If you disable it and then try moving EQS testing pawn.
Oh, there we go. That's much nicer.
So it's currently it's not that impressive, but if you start like projecting points to nav mesh so that they snap to nav mesh, stuff like that,
right,
that will be more impressive.
Because we'll want to be the. I know for my own writing on the. Why is it not displaying?
What's not displaying?
Yeah. Oh, do we not? We don't have. We're gonna run into a really harsh issue here in a second. Because we don't even have our nav mesh laid down for this map. So let me go ahead and do that really quick.
Details.
Minor. It's okay.
Who needs nav mesh?
We don't.
Well, you know, we could always use, there's a special mode in BT move task that just allows you to move in straight lines without, and then you don't need any navigation mesh. It just goes in straight lines. Obviously, in this case, it would run into obstacles, but you could do that if you wanted.
No, let's go ahead and let's. It's a combination of things, right?
Yes.
It's like, and nav mesh is nice because we won't have to figure out how to
Like it's
get
crucial,
around things for us.
It's crucial for non-trivial AI.
Right. And so since this will now, let me turn back on the visualizer. So if we come in here, we can actually see that we're calculating nav mesh in here. So when I was actually doing some write-up on this, there's some values that you can change to like pop these up onto the surface, which is super nice. So let's go back into our find hiding spot.
Yeah.
And we're doing a nav mesh trace, and I believe when I did this, all you needed was a quick 2048 in one of them, and then boom, we'll be able to decide whether or not our hiding spot on top of our little structure right here is acceptable or not. So I think these are just slightly above 1028 or something along those lines. So now that we have all of our points in our grid, they're all showing this light blue, which just means, hey, we're a point.
Yeah.
So now we need to start going in and asking questions.
Scoring them or filtering them.
And we can just do that by...
So before we do that, because most of the queries we want to ask, like most of the questions we want to ask relate to the player, right?
It's true.
And player is, like not even player, enemy. Enemy is not a engine level concept, so we need to add a way of telling EQS what is the enemy. So we need to create an EQS context.
Okay.
It's a new blueprint class.
All right, so I'm creating a new blueprint, and these you can find under ENV, and we're looking for an ENV query context blueprint base.
Yep.
Gonna select that, create it, and we're gonna call this enemy context. And save that out, double click it, open it, and it's just another blueprint.
Yeah.
And so when we create these, all we need to do is choose a function to override.
Yep. Yeah.
So do we want to, I guess we want to return, well, in our case, we only have one enemy, but we may have more enemy in the future.
Yeah. So contexts allow you to specify multiple contexts.
Contexties.
So that you can find like locations not visible from any of my enemies, if you have more. Or generate points around multiple locations, like generate locations around all, like poker tables in the saloon, stuff like that.
So I'm going to go ahead and provide an actor setback. That seems...
No, we, well...
This is for the player context.
If we are the question is...
enemy.
Like, so it's called enemy, right? We know what was the name you used? Enemy context.
Yeah, enemy
which
context.
means one enemy.
One enemy. All right.
So just a single actor.
Words mean things,
provide
right?
single actor.
Okay, so we're going to provide a single actor.
Yep.
There we go. And
so it gives you an actor that's asking the question. It doesn't have to be a pawn. You can have like anything. It's who's asking the question. So just like the simplest way would be it's. I
mean, for our testing purposes, get all actors of class.
So no. First of all, we need to get access to the controller of whoever's asking. But there's a super easy function. There's a function super easy to use. Get AI controller, and you can call it on any actor, and it will just give you a AI controller associated with this actor, regardless if the actor is a pawn, a controller, or just anything else.
So the querier is returning our AI pawn.
Well, it depends on who's asking. It might be a controller as well.
Okay. What happens if we get the AI controller of your AI controller?
There's none. It will. So if you call this function on the AI controller, it will just return self.
Okay.
I've taken that into consideration.
Okay. So this is good.
Yeah. It will just give you a controller if there's any.
And then
it's also possible that there's none.
Right.
But so you could, like, if you wanted to be like fully correct, you should check if it's null here.
Yeah, we would have a not equal and a branch.
No, I meant to check if the controller is not null.
Oh,
because the query, if the query is null, then there's a bug in C++. Because it should never go that far if null, if like the owner was null.
So if not null, we're going to go ahead and allow this to continue on. And so we're going to have our AI controller, which means...
You can just cast it to our AI controller type and just grab enemy from it.
So, I'll reroute this here in a minute before we start dumping all this stuff on the Learn tab. And if the cast succeeds, we get enemy.
So I think you need to set this enemy to a temporary variable, because you have only one return node and you need to plug all the possible exits there, I think, right? I might be mistaken. That was the case in 4.7. Well, if it compiles, it should work.
Yeah, no, this should work.
Awesome.
So
the note is it doesn't.
the execution path doesn't end with return node. Yeah.
That's
yeah,
what I meant,
I guess, you do all of these, right?
Yeah, I just wonder what would happen, but yeah.
It
should be fine.
Which is interesting
blueprint, it shouldn't crash.
because normally that's okay. Like it just, because the return node, okay, whatever. But it's all good.
Yeah.
We have everything hooked up. This will potentially return null if for whatever reason any of these fail out. But that's okay because EQS handles that, right? Like it'll handle a null return. There's nothing here. It's okay. So compile again, save that, and back in our EQS, we have our grid, and so we'll have a player or an enemy context that's being dropped from our perception. So we'll have that point in space to be able to define, hey, where do I want to go? So what kind of tests do we want to start running now? Because we have a...
So first of all, add a visibility test from the enemy.
Okay. So we're going to do a trace test.
Yeah, so bear in mind, EQS is still kind of experimental. I mean, under the hood and the queries we've created, it's all working solid. It will not get changed, except for improvements. But the editor is like far off. So for example, in this case, whereas like it's a Boolean test, either you're visible or not, it's very confusing to get it right, to make it filter out the stuff you want, because it just says bool match, and I don't really know what it means.
Right.
So I think it means the result of the test needs to be whatever you set there.
Right.
But
that's okay.
So if we want stuff that's not visible, we need to like untick the Boolean match here.
Right. So we would do...
I think. If it doesn't work, then we will just change it.
Well, it doesn't work, we just change it back, right? So if we come back here and, now everything...
Because we don't have an enemy.
Right.
Once we start using this kind of custom context, we lose the ability to use the EQS testing point, unless you add extra logic to the EQS testing point, so that in your enemy context, you can also check if this is if it's not an AI, because it probably doesn't have an AI either. You can also try to get whatever actor is set in the EQS testing point as a test enemy.
Gotcha. So how do we want to?
So I would
so the querying actor could return the EQS testing pawn, right? And then we could just say if EQS testing pawn, then just do a simple get all actors of class, and then
just to enable the testing,
and then we just do a third-person character. That way, this will only return the character. There's only one in the scene, so we can just simply do a get 0 out of it. And so I just need to know, so how would we test whether or not this is an
So, but the problem with this kind of setup is that you need to add a variable to your EQS testing pawn.
Right, because we'll need to be able to set this.
That's why having it as a local variable is a good idea.
Yep. Nope. I see what you're getting at now. So
it's like be prepared.
Be prepared. All right. So we'll do what do we
like temp enemy, for example.
Yeah, we'll do temp enemy, and we'll make it of type actor. There we go. And our temp enemy, we'll just go ahead and do like that.
Like that.
And this, we'll do a set. Expand off of this, plug it into there, drop that into there, come over here, plug that in, plug that in.
No, but now you're making EQS his own enemy. EQS testing pawn.
Mm-mm. So this is going to get all third person characters.
Character. Okay.
Yeah, and then
This
it's
is
going
like
to return.
I can't really see it.
Yeah, I know it's kind of squinty.
Yeah. Okay. Cool.
Yeah, and then so
that-
all I
that
need to
should
know now is what is it? Type or class. Get class, and then
You can try casting to the EQS testing
Oh,
pawn
okay.
as well.
There we go. That's actually probably better. Cast
easier to set up.
EQS testing. No. Well, yeah, no, that'll work because we inherit from it, right? So that can just
Yeah.
go there.
Yeah, that should work.
And if cast succeeds, we go this way.
Yeah.
If cast fails, we go this way. So with that, we save, cross our fingers.
Yeah, but there's two third-person characters on the map. No. So
No. There's not.
seriously?
Nope. That dude is an AI character. He is of this class.
Ah, okay. So he's
and
not.
then there's this guy. who
they're
is the
they're
actual-
not they're not family. They're not
No.
related.
Nope. Not they're both characters,
Okay.
but that's as far as it goes. And so now that we move, okay.
Yay.
So now we get yep,
the
got it
visit.
backwards.
Ah,
No, we got it backwards.
Yeah,
That's okay.
That's what I mean. That's what I mean. The UI is like really long way off still.
All right.
So like community, if someone wanted to make it right, then feel free.
yeah.
We'll take any improvements.
Exactly. And so now we can see that, okay, we're getting the locations that are hidden from the site of our...
You can disable these labels if that gets in the way of like seeing what's
they're a
going
little intense. So, and we'll turn it back on here if we need to show that, because some of these colors can get really close together. It goes from green to red, but some of the middle oranges and whatnot start to blend together. So okay, we got that. So we know that one of these is going to be good, but currently they're all weighted 1. So we need to have...
one thing you might notice here is some of the locations you would expect to be filtered out are not filtered out.
Like that one right there.
Yeah, because it's like navmesh is just a simplification of a walkable space, but it's not like especially in z-axis, it's not the like precise replication of it, so that you might need to bump the points up so that the testing results are proper. So
And also
there should be an option for it in the EQS generator,
yeah, there's
like vertical offset or something like that.
Yeah, there's oh, where is it? Filter, yeah, post projection vertical offset.
Yeah, so we just bump it like 80 units.
80 units. Yeah, we'll do it like 80. And then
It's like basically a half of character's height would make sense.
now, so when I
So-
did the local ECGC out here, we had some AI guys in the front row, and they're really, really big guys out here, and they were talking about, other games. Actually, what they do is they do a per bone trace for their AI, so that they're allowed to. So like if for fewer AI, like tighter kind of combat situations, so they're instead of doing a trace against just the center of mass like we're doing, they're like, nope, even your little fingers out here on the end get a trace just in case one's hanging out.
So if you
across
have C++ access, modifying it would be really easy. I mean, so
It'd be heavy in Blueprint, but
yeah, you don't want to do it. In Blueprint. So it's like two ways to. You would need a dedicated EQS test, which currently you can do only in C++.
Yep.
But then, like, the sky is the limit. Whatever you can check on AI, you can just do it.
exactly.
And
I'm gonna close.
speaking of visibility, you can do that to AI perception system as well. You can either you can either derive like create your own sense. If you want it to be site and reuse some of its logic, you can derive from view AI sense _ site class. If not, you can just implement your own. And or you just override. There's a interface you can easily, like if you have access to C++, it's easy to find.
Yep.
And that allows you to just specify points you want to test against. So for player, you can specify like 100 points, and if AI sees any of them, it will just assume it sees you.
Right.
So we're prepared. It's doable.
All right.
Not in Blueprint because
Well,
C++.
yeah, it gets I would love to see them in Blueprint, but at the
Yeah,
same
well,
time,
I mean,
they
it's
get,
doable,
I
but
know it gets heavy, right?
So
Like,
one of my problems, because it's not a big problem to give people a way to create EQS tests in Blueprint. It's actually on my list to do. But the problem is, like, how do you communicate that this will be expensive? Because if you, like, even in this case, you generate how many points? It's like at least 100, right? It's more, a lot more than 100.
and if you were to do your own custom Blueprint trace, I mean, you're slowing yourself down
that would
by
be expensive.
the factor that Blueprint slows you down, and so
that would be like a kind of advanced option, but we should do that because, like, even for testing purposes, if there's even a point of having this kind of test in C++ later.
Exactly, I care about the result. We'll make it faster.
Yeah, and if it works, you just give it off to your C++ programmer.
Exactly.
For example, or I'm doing a lot of stuff in the pure blueprints just to see if it works, and if it works, and like get the details right, and then I go to C++. That's like very often.
All right. So now that we have a listing of locations here that are looking okay, we need to start weighting these. Which one's best?
So which one's best? That's a good question. So first of all, the further away you want it, right? Like the far away points.
Well, I guess. I mean, it depends, right? Because if we go far away, this point's going to be best.
Yeah.
But is it really best? This isn't really a hiding spot. This is cowering in the corner. Whereas a hiding spot would be more like, in here or over here, not really these out here. So it seems like actually you want to do something that's like maybe two distance tests where you're kind of waiting in the middle of this, or do closest. But closest is going to drop you here. So is that really also a great hiding spot? I mean, it's for a roach, sure, a roach AI, like, yeah, he just runs to the nearest safe spot. That seems to make sense, but we're talking about more of a dude.
So you can have like multiple points, like multiple distance tests with different like properties and different contexts. So you can you might like prefer points as far from my enemy as possible, but you also might want points as close as possible to yourself. So, and those things will sum up based on the like using the weights you put here, because that, like, the points being closer to me is more important than being far away from enemy, for example.
Okay, then we'll do that one first. We'll do test mode 3D distance, test distance 2, the querier. So from the point to the guy who wants to run away.
Yeah.
And we don't really need to filter. Let's just score for the time being. And then we'll just use a linear score factor. And with that...
So one of the missing features here, sadly, I've noticed it recently, is that you can go back to the query.
Yeah, is it?
Well, that's, you can show different, like, subsequent steps. So the step 0 is the generation step. The step 1 is the first test. Yeah, although the tests might be in a different...
There we go. It just, like I said, the colors are so close together that you just need to bring back the labels so we can see that is a, it looks like a 69 in there. And there's some 71s and whatnot across. Yeah,
and like you said, the furthest one is score 1, which means, like, currently it's perceived as the best choice.
So I have this backwards then. So, well... this is from...
Well, currently it's set up so to prefer the furthest point. Furthest from me. You want it like so inverted.
We want it inverted.
So, like I said, one feature that's missing, there's no way to prefer points in the middle, which would be like a Gaussian bell curve, like something that has maximum value inside. That's on my list to add.
A spline editor right here, so we can just...
That was actually one of our goals, but it's not that easy to just
no, it's really not.
That would be ideal. That would be ideal. Yeah. You have like a couple of predefined curves, and you also can specify whatever you want.
Right, and then you'd have...
that would be super powerful.
That would be, it'd be pretty sweet. All right, so now our closest one is being weighted the best since we inverted it.
Yeah.
And something I've run into, I don't know, you can do something like this, but it ends up being that you're weighting
it's basically the same as...
Like, it's basically inverting it, except you're getting heavier values out. Like, instead of being, like, so within that range, it's just like, okay, well, this is the worst. It's giving you the worst rather than giving you the best. So some of these higher ones seem to like we could actually spike pretty high.
Yeah, well, like I said, the UI is like it's confusing. First of all, it's like trial and error still, unfortunately. If you know what you're doing, after some time you get feeling for it pretty quickly.
Exactly.
But we are looking into improving it. It's just not enough human resources. Seriously, it's just like you might say there's 2.5 full-time AI programmers in the whole engine.
Mm-hmm.
2 actually, because there's two are half-time.
Yeah. Yeah.
Yeah. So right.
So we're going to do another score only. So we're doing another distance. And instead of to query, we're going to do to our enemy context.
Yep.
So we want furthest away from that. So when we drop it back in, now we're going to get some rather weird, everything's kind of high.
Kind of high.
Kind of high, but
so you can
we're
use
seeing some actually really good hiding locations. Like, but what happens if we, we move? I mean, well, still 94, 90, but
so
no,
wait.
These are still best.
So one of the things you might notice, the last property in the EQS testing pawn is the run mode, which is like different. You get a bit different results.
Oh, like, single best item.
Yeah, single best item, it's
that one.
what's actually being used. But the debug drawing might be confusing because like you can see there's a lot of points that have more than one score. The problem is like the final best score, the final best item is just hard-coded to have score 1 and the rest is not being touched. That's actually something that has been already changed in the main branch. Because that's confusing. Also, you might also see there's like a number, the way single item mode works, it saves the most expensive test, which is site test in this case, for last. And it means it just gets all the points that passed all the previous steps and accepts the very first one that passes the expensive test. That's why you only see like a bunch of items that failed the trace test. And all the other green are green ones because they didn't fail the test, but they didn't, like there was no point in testing them because they were like so low in the sorted set that like there was something a lot better that has been tested and just succeeded.
Gotcha. It's really cool though. I'm sorry. That's,
you can always rewind and listen again, maybe it will make sense. I mean, I'm not making perfect sense because I'm mumbling and I'm chaotic in nature, so.
It's all good, man. It's all good. So I'm just gonna swap it back to all matching. Although the single, I mean, this is the mode that will be used in our case because we're looking for a single point to go to. Yeah, and it looks like it's actually we're getting some okay hiding spots.
Yeah, reasonable locations.
Yeah, these aren't terrible. So, and if we wanted to kind of like ignore our little hump here thing, then we could just raise the actual grid for testing so that potentially we could see over it. So that's really good right there. And actually, at this point, technically, won't this work?
We could give it a try.
I mean, I think. Oh, there goes our pawn. Bye. Fell through the world. I was always wondering what happened to them. Or
that's what's happening.
Nope. And you said,
did we tell AI which query to use?
No, we didn't because it didn't exist at the time.
Yeah.
Good call. And
but wait. Let's use this opportunity to show log visualizer or visual log. So I think there is a button somewhere to enable it, but just type like a console command. You didn't, vislog, vislog. Yeah, and it opens like summons a UI for it. So you basically start recording.
Hold on, let's just see if there's a developer tool.
Yeah, it's there. And
where? Which one? Yep, there it is.
So you don't need a console command.
Yeah, it's under developer window developer tools.
I'm an old school guy. Whenever I can avoid using a mouse, I'm avoiding using a mouse.
So we can just start a recording here.
Yeah.
Do we play or simulate?
We want to play.
Okay.
But just put it somewhere that we can see both the game, and you can. It's just a regular tab. You can just put it down with Content Browser, for example.
Okay.
You should be able to. I mean, just
Doop, doop.
yes,
There we go.
awesome.
And now we can start recording, hit play, and now things are happening, and it looks like we're getting little tick marks. They're every second, so that's probably the behavior tree running.
Yeah, that's every 5 seconds or whatever we put
One.
the wait for.
Yeah, I dropped it to 1.
Yeah, okay.
And
So-
so now we have some data here to look at.
And yeah, go to AIs.
Nice.
And what does it say? Just the entries, the log text you can see, it's per, like it's in the entry corresponding to the frame it has been recorded in.
Mm-hmm.
And all the stuff, all the AI logs that happened that frame is like only in this one entry. So we can, first of all, easily tell what's the like time relationship between different events.
Right, what's happening first, what's happening
Yeah,
second.
and it also just tells you whatever happened that frame. And what does it say?
Well, it looks like
Activation
we
root.
activated a root node, testing node, real root, child execution forbidden by Blackboard.
Okay, so in this very case, it means it just didn't execute this sub branch because AI player was not visible. But on the left, like in the left from the text
right.
displaying, is the AI snapshot, which I'm calling, and it's a snapshot of AI's brain when like during that frame.
Mm-hmm.
And there's also a Blackboard
Nice.
printout, so we can see if
Well, we did have
enemy was there, but the enemy was not visible. So we need to find a location, like we need to find an entry in the visual log that
Mhm.
has the enemy visible to true, because that's when the actual behavior should kick in.
Did I run? I ran in front of them, didn't I?
Yeah, it's like somewhere later.
Is this?
We're not setting this ever. That's
Oh.
why.
Are we not?
I don't think so. We were setting enemy, but we're not setting the visibility.
Oh, that's right, because we have the bool in there.
Yeah,
Yeah, we're not doing that.
yet.
We are absolutely not doing that. All right, we need to do that. All right. So, how we want to do this?
So we already have an AI controller, our custom AI controller.
Mm-hmm.
We already have this event that should trigger the lower in the event graph. There's this is the perception event that's triggered.
That's right.
when
We
get
never
any
went through
perception.
this.
Yeah, so we need to get the element from this
Mhm.
array, ask AI perception component about information on this specific actor, and we will get
Mhm.
like a rich perception information, which we will be able to use to figure out if the AI, if the player was seen or just lost sight of it.
Okay.
So
All right. So I know we're going to eventually need that down there.
yeah,
But we also need, so we're also going to need, I'm just going to go, I'm going to, no.
yeah, you just
Give
need
me-
a AI perception component call.
Yep. So we got that. We're going through each, and now we need to, well, we need to know that we found something that we care about. So we can either do a cast in this case only to the third person player, which would make it just to our use, but that's not the best,
Could.
which would just end up being, our dude. But
So okay, so
but
first
we
of
wanna-
all,
but we want it to run away from.
First of all, you need if you just care about your enemy that's being set by some other system, you can
Mhm.
have a service in the behavior tree that does that. For example, you just need to check if this actor is by enemy. If it's not, then I don't care about the perception. For example, that's one of the many ways to do that.
Yeah,
So
we could,
check it against the enemy, to give it
right? But how do we know he's my enemy?
well, because we've said it in a hacky way.
Ah, I see.
So
So,
like I said,
you just want to do a test. If this equals the guy that we
Yes.
had before,
Yeah.
he's obviously our enemy.
If you
And then
yeah.
if that's the
If-
true,
so basically, we're answering a question: if this is the perception of my enemy,
hmm
and if so,
And what I would see is something like here would define, call it teams. Like you would grab your guy, everything that's being perceived, and you would say, hey, are you of something I want to kill?
Yeah, if you want, like that's the place to do some filtering.
Exactly. So now we're gonna go here, we're gonna go here, but we still need to set that bool.
Well, it's already our enemy, so we don't need to call
Yeah, that's
it.
true.
But we need to, first of all, grab perception information about this actor from our perception component.
Okay.
Like I said, well, this framework, this workflow is not ideal. We'll make it easier to use, but it's functional.
Okay. So
Get actor's perception.
get actor's perception. Okay.
Yeah, and you plug in an actor, and as a result, you get a structure.
Wait, do I?
Yeah, this actor.
This, okay.
Yeah.
And then this is only going to run if now our perception is our enemy. And now what are we actually getting here?
You can break it.
We're getting a target, last sense stimuli, which is an array, and is hostile.
So we have only one sense, so we can directly grab the first item from this array.
Does it get 0?
Yep.
Okay, and now what is this? It's it
another
says an integer.
thing to break.
All right, we'll break that one. All right.
And there's the meat.
Yep, there we go. All right.
The actual data.
So we have.
Like I said, it's a bit convoluted.
Yeah, but I mean, it's.
Like I said, it's functional, but there's a lot of room for improvement in terms of ease of use.
Right, but
so
it looks like we have a successfully sense that we
so
can
that's
play
basically
off of.
what will tell us whether we've seen, we see or we don't see the target, the actor in question. Well, what you doing?
I'm setting our bool.
Yes,
Right?
right. You're right. I'm stupid.
I mean, that is the next step in this.
Yeah,
case.
yeah. That's all.
I was just waiting for you to talk before I started jumping in and saying, all right, so what we're going to do now is we're going to do another set of on our Blackboard, which will be our bool, so that our dude will actually be like, hey, I've sensed the dude that I want to kill. Run away from in this case.
Yeah.
I'm sorry, I'm in the other end of this mode.
So this event that we're handling basically now should get triggered only when the perception changes, which means you will get a notification that, oh, I've noticed this this actor, and also you will get a notification, oh, I've stopped sensing it. But under the hood, AI is constantly getting updates about the location and stuff like that. So there will be a separate event for that.
Yep.
And I will add events like simple events like on seen enemy and like things like upon sensing head, or still has.
So I need to know my name here. So I've created another key variable, plugged it into the key name.
Yeah.
And
So
I believe that it is
value.
enemy visible, but let's go to our behavior tree.
Yeah, just copy paste.
Wait, you can do that? I can just.
I'm not sure if you can do that, but like
I can do that.
Like I tend to copy paste names to the degree that I multiply spelling errors in the code.
Absolutely.
So we used to have a function Tigger event, for example, in AI.
Tigger?
Tigger event. And one of the programs, Daniel Broder, actually, he found this misspelling, but he found it so amusing that he didn't change it.
He didn't change it. All right. Is that still in there?
No, it
something
has
for
been
people to go
changed
look
since.
for?
But
That'd be awesome.
Well, I think it has been changed, but give it a try. I mean, or like grab some old sources and just have a laugh.
All right. So, okay. So in our behavior tree, now this will be set.
Should
be set. We don't have our EQS query. So let's go ahead and set that to our find hiding spot template.
That's the second thing that was wrong.
Yep. And this is returning the single best item. Okay. Setting our hiding spot. We're moving towards a hiding spot. We're waiting 1 second. Now, this is a selector, yeah?
Yes. Right, that's wrong.
So this is gonna succeed, and it's gonna be like, nope, and we're gonna constantly.
Yeah, I'm done.
Out.
Yeah.
So let's.
It needs to be a
sequence. And so we can just drag that. And then
I wonder if anyone noticed in the community, like in the chat.
I don't know. Maybe Alexander can type that into our little question doc. Like, yeah, they totally nailed it. Yep, don't want to drag.
You're dumb. Why are you doing stream?
Why you select your sequence node? All right. So now this will fire, return true because we found something, or if we didn't find something, this will just fail out and
it will fail.
go back to our wait. And then if we find something successful, we'll move to our hiding spot. I think that's it. If we spelled everything correctly and whatnot, we should be able to press play. Now, he can't see me back here, I don't think.
Maybe.
Maybe? Nope. Oh, there it goes. But he can't see me, so he's like, I'm totally hiding, dude. He's like,
Right.
hey, I can totally see you.
Well, so he doesn't see you. That's why he's not even running the behavior.
Yeah.
So,
So
we
his vision radius is 90 degrees in front
yeah.
of him.
In this
And
case,
it's like, I'm hiding in the wall.
in this case,
Can't see me.
in this case, you might need to just increase his
Yeah, let's go ahead.
peripheral vision to like 360 or
Yeah, let's go ahead.
180
let's-
actually.
Yeah, let's do let's let's do that. We're currently 90. Let's do 180. So that way he won't just be like, "Oh, I saw you. Oh no."
Kudos to anyone that can do that. Just
Wait a minute. Why you no go?
okay. Debug game. Press the debug magical button.
Okay, so our
He's
behavior
in-
tree is their perception component.
We have what do we have? Enemy visible false. So what did you put there? Wait. It means like we fail some of the
Are we
like
failing?
handling of the event because it's just not because you can see like the ball is moving along,
Yep. Yeah.
which
we're-
means the perception works.
Yep. Oh, geez. There
suddenly-
goes
so
EQS.
We might have a bug somewhere in that blueprint code.
Yeah. It looks like maybe we have some logical.
And there is also EQS debug drawing text you don't see because it's you've just seen it for a second there.
Yeah.
So
Yeah. Wow.
Yes.
There's a lot of data being thrown up here. All right, I'm gonna.
You can disable the EQS drawing, for example, by pressing numerical keypads.
Okay, hold on. Let me. Whoa. Let's stop. It choked out pretty hard there.
If you switch to other application, it will start chopping,
Yeah.
like having updates every second or half a second.
Yeah. All right.
So first of all, we need to debug why. Like
So
if we're getting that information and if there's a bug in our
Well, it
handling
looks
of the
like-
information.
it looks like we're not handling this because we start off in his perception range.
Mm-hmm.
So
Right.
does perception maybe doesn't fire off right at the start? It's like he was always there to begin with, so the event never gets.
So
updated.
if you leave and get back, it will
yeah,
just
so
kick
I
in.
bet if we
No, you need to go outside the,
that's
the
right, I need
other
to go out this
outer
radius.
Yeah.
and then come back in, there
Yeah.
he goes.
Ha!
So
You nailed it.
Yeah, so we're not handling
That's a good
if he
point.
starts in the perception radius.
There might be a bug.
So
So
that's just awesome. Just like all the information. What's going on here?
so I bet there's a way to handle that. Okay, I know.
Okay.
So first of all, we are setting the enemy after a second of game.
Mm-hmm.
That's one issue here. By then, we already have information about
About the enemy,
about
so-
this actor.
So we're actually failing right here. Like
Like at the beginning.
yeah, because it'll fire. This will fire and be like, oh, enemy's not set. Don't care.
Yeah, but at some point it will. Right, but it only triggers when the perception changes. So
Exactly.
That's,
so
yeah,
since
that's the bug.
We're not
basically.
changing here.
It's our bug.
Yeah.
We're stupid.
Now,
So I'm stupid. You're just clicking.
yeah,
It's my fault.
I'm just clicking things.
No, you're doing fine. Like how to get out of this situation without getting people mad. And shit.
Yeah. Well,
Like I said, I'm
okay.
chaotic. It's
So we could. Well, we don't
So
know
we-
the order things are going to be created in.
so-
So this isn't. This we.
so wait.
kinda-
So ideally, that should live in the set enemy function.
Well,
Because like
actually-
when you're setting enemy, well, we need to update the associated Blackboard entry as well, like for visibility. So
Right.
you set an enemy, check if your perception component has information about this enemy, and if so, just use it. And if not, you need to wait for perception
Right.
to update.
So in our case, let's since we're kind of cobbling this together instead of saying, "Hey, is this of something that I want to destroy?" Because we don't know the crate order. So this works out okay until we need to update. But really, we'd want to handle that like right here because as soon as I spawn, or as soon as he spawns, he should get a perception update. Now we just need to know, is the thing that I'm now perceiving something that I want to run away from, or I spawned and I've updated, the thing was already there that I want to run away from. So
Okay, so ideally, the way to implement that would be to have a function called update Blackboard entries for enemy or something like that, which would just get an actor or update Blackboard entries for enemy, which would set Blackboard enemy key, and it would set other enemy related keys to appropriate values, which means it would get perception about this actor and like just fill the Blackboard entries. And we would reuse this function both in set enemy or actually just in set enemy, we would use this function.
Yeah,
and
it just seems
in handling the perception notifications, if we like wanted to change enemy, the set enemy function will just handle that as well.
Right.
Like, because we will use that function.
Right, because it seems like, I mean, we have the setup here for it. We just need, because this is firing, but this right here is this is null. So we need, we would just have something here that's like, I don't know. We could do something like, we could just do another simple. We just do cast to third. This would be actually more appropriate if it was like, hey, get all, this would be your super character class that everything inherits from, and it would have a team variable or is enemy to whatever, and then we could pull off here and get that and then do a quick comparison. But since we're only caring about the third person, we can just go ahead and work this like that. But here, I mean, if this succeeds, great. We're going to set it to our enemy. That's awesome. But we also still need to make sure that, you know, we're perceiving everything all right.
Well, my point, which I explained so terribly, was basically to get all this like long string of calls.
Yeah, all this craziness.
To make that into a separate function. Is like update perception Blackboard keys related to enemy perception, which in our case is just one key, but could be more. And then call it both from set enemy, and we could use it here as well.
Okay, well,
that's the whole point of making a thing into a function, so that you can reuse the code.
Right. So let's go ahead and, you know, let's
for
collapse to a function.
There's an option like awesome.
Yeah, we can just be like bloop, function done.
Pure awesomeness.
Yeah, and so we'll call this one update enemy or update my Blackboard keys. Blackboard keys. And now it inherits, like the names are really bad, so we need to come in here and make sure that, you know, we're actually, you know, setting everything else in here will be fine. It'll be exactly the same functionality. We just need to know that our target is, well, it's basically self in this case. Wait, where was that one coming from?
Yeah, we don't really need that key, I guess.
It was coming from, oh, it's AI perception.
Ah, okay.
So
it's not self, it's
the
perception key.
It's the perception component.
Yeah.
So we'll go perception component, and then this is it's technically the enemy.
Yeah. Well, we intend to call it only for enemies, and we are going to update enemy related keys in Blackboard. So the name is not quite descriptive, but
yeah, that's okay.
Yeah.
And since now all
words,
of that,
words matter.
Words mean things.
Mean things. Yeah,
right.
That's
So instead of doing that down there, we can actually now just copy this entire chunk, and if it successfully casts to that, then we can update it. But really, what this is saying is like it doesn't matter. All of this is going to simply update all the time.
No, you don't need to do it this way, because like the false part of the branch, it's going to trigger only until player is not the enemy, which means we just need to put the Blackboard updating functionality inside the set enemy function, like a function inside a function, and we'll just, as soon as we set the enemy, it will populate the Blackboard with proper values, and it will just work.
Okay.
So just move the call, and we'll.
Where do you? Okay.
Destroy this casting
We don't
here.
need that. We don't need that.
Yeah, we just need to call the update my Blackboard keys from inside the set enemy as well. The set enemy function
Actually, okay.
somewhere here. No, not here.
Oh, okay. Yeah,
Yeah,
nope,
the
I see.
other
I
thing.
see. So set enemy, and we need to update my Blackboard keys.
Yeah.
And so setting enemy. Okay.
You need a perception component here,
Yep.
and the enemy is the enemy.
Yep. Enemy. Enemy.
That should do it.
So okay. Now let's go back here.
Save all.
Yep. Control S. Quick. Now it looks, but we're still going to run into the same issue because this is being delayed.
Mhm.
Set enemy's never going to fire.
Mhm.
We're going to start inside his visible radius. This
Mhm.
is only going to be fired once. Enemy is not going to equal anything.
But your
so this
perception
fail out.
component has this information. It just stores this information.
Okay.
So regardless when it triggers, it just see.
I'll be. All right. All right. So we can chase him around, and he's just going to keep.
Kinda keep.
Yeah, he's.
So
His grid is limited, one, so he's doing the best he can.
Yeah.
And we're also not doing any other intense
So our
tests.
query is not too sophisticated
Right.
yet.
I see you, bro.
So now the like all you have to do to modify this behavior is just modify the query.
Yep.
We are a bit limited in terms of readily available tests. So, for example, it's not really possible to, like it used to be, but got broken, to specify that, like, to tell EQS prefer the points to the side of someone. Currently, and that's where the bell-shaped curve would be handy. Currently, you might prefer the points in front of him or behind.
Yeah, there is a really janky way to do it with dot product, but again, it's very janky.
Like using the
There's
minus weighting.
It's like you filter.
I
You
remember
filter the
it being
range.
doable.
Yeah, it's like you filter the range based off of like 0.25. Wait, no, that's min value. Like 0.25, negative 0.25 and 0.25 because it's a 0 to 1 range. I guess you could use half and half, and then that will filter those out, and then you can score them.
Yeah, but we don't want to filter them. We just want to prefer the ones to the side.
Yeah.
Well,
In which case,
well,
yeah.
although I think this could be achieved by specific weighting, like
clamping it?
weight.
Let's just do
Like-
let's just do a score.
Yeah. So, but we can play around with it and look while using the EQS testing point to just figure out.
Yeah, let's do a score minimum negative 0.25. So I'm just clamping the scores down. Wait, no, this isn't going to work either, is it?
It's advanced EQS
Yeah.
testing, tweaking.
So I don't think this is going to do what we want.
Um,
And am I doing...
switch over to the all matching. This will allow us to
Yeah.
see the
Also, I need
influence on the
to-
whole query of whatever we change.
I need to also change my context. So line...
Well, that's yet another confusing bit.
Yep. So the enemy context is really I want to prefer from his side.
Mhm.
So now his rotation defines the first point in that, and then we'll go to all matching. And I'm going to move you up a little. I'm going to rotate you. So technically speaking, some of these things over here should start. Okay, no, let's do the opposite. Let's rotate them towards. There. And then we do highlight mode, no.
Round mode. You want to see?
Yeah, I just want to filter, I just want that one test.
So okay, so the problem in doing that is you don't know which test is that, because if you go 4,
Yeah.
it's after performing like 4 steps. You
Yeah.
might figure out what's the difference between like switching between 3 and 4.
But what we can do is
Well,
just
and you
disable
still-
these.
You could do that. That's
and just be
actually
like, there you go. All right, so
that's not quite what we wanted.
no,
Nah,
no,
no.
that's, how does that look? Nope, it's still doing,
Well, it looks like it's using
what is our second?
just it's using wrong direction apparently.
Yeah.
Like try rotating this guy and you'll see that like it changes or not. No.
No, it's being weird. Look at that. Like, as I'm moving around, that should,
That's intriguing.
it's this rotation, but it's from, okay.
But
th-
it's
we're
a
doing,
different location.
yeah, we're doing this part wrong.
There is something wrong. That's
2
for sure.
points we're doing from context. Oh, that's right. We need to change queried item there. Save.
Okay. Yeah.
All right, we're starting to get something now, but we still like things in front of him. And then let's just see what happens. Nope, that just gets us backwards.
hmm
And I know I've done this recently.
So like I said, there was a function like the tick, magical tick, it ticked,
Yeah.
that was inverting it kind of, and but currently it got removed while
No,
introducing
yeah. Wait.
the curves.
Absolute value.
Okay,
That'll give us that.
and we need to
And then
invert that.
And then we'll invert it.
If we can, we should be able to.
We'll either do -1 or perhaps inverse linear will work. There we
No
go.
way,
Yep.
magician.
And since we've clamped it out, we're really, hitting the lower end.
I don't think we want clamping, like filtering out points that are outside.
well,
or
now remember, we're not filtering them. We're just clamping the values. So
Okay, so it gets as
yeah,
the
they're not
lowest
filtered,
possible
we're just
score.
scored. So these things are like really high, and then we're like anything beyond that's going to get
Yeah,
really slammed down.
I see you've wrapped your head around it.
yeah,
That's
and then
awesome.
we'll do bloop,
Maybe you can
bloop.
suggest some improvements to UI. That would be awesome.
And then if we go back in, we're going to still see that, a lot of these are just going to be weighted really high. And that's just
Wait, so maybe that's something we actually see now. If you clamp it too much and there's no point inside that preferred
It's
angle,
true.
all the rest will have 0, which means this test won't matter
it
at all.
matters
Yeah.
absolutely nothing. So we could weight this like really heavily. And I don't see, yeah, you're right. It absolutely doesn't make a difference.
Mhm.
So what we should do
We just need
is just
the higher angle there.
Well, we'll just it should be 0, 1 because it's absolute value. We don't have to worry about the stuff behind because again, we're doing that. And then suddenly, yes, we're favoring stuff off to his side there, off to his side there,
Awesome.
and we don't want stuff that's directly in front of him. So this should give us some differing behaviors, but it's also,
Something we wanted to avoid as well.
yeah, it's also something that we can
Yeah, but
note some hilarious
that-
behavior.
but that would be the first time he's kind of running.
Yep.
But now he should be just running away from you.
Yeah, he's favoring the side. It's like, what are you
Yeah,
gonna
but
do now?
Yeah,
It's like, oh, I'm gonna run
because
through
there's no
you.
jump down links.
Yeah, there's no jump down links. So, and there are ways to like mess with it a little bit. Like not right now because you see in my character, as I'm moving, he just kind of rotates to face that direction. But if we had strafing it, like you could mess with him and be like, oh, you totally want to go run over there, right? Because I strafed into from the side here. I'm facing forward, and you're like, okay, I'm going to run off to the other side. So it's not foolproof, but for a basic,
Yeah, I would say
I need to get away and find a safe spot. And I mean, outside of really getting into a custom generator, where you would like do a grid and then cast back towards yourself so you find walls to hide behind, like really this is pretty good.
So one thing we could add to make AI a bit more responsive,
Mhm.
because currently if you're you're running behind him and he finds a spot and he's just
and
going to
just-
that
just
spot.
go, and it's like I'm still running. It's like don't care.
Yeah, he doesn't care anymore. But if you just go back and suddenly he doesn't see you anymore, he will continue running now.
Mhm.
But there's one simple thing we can do that will make him stop as soon as possible,
Okay.
which is in the behavior tree.
Okay. Let's go. Behavior tree.
We can configure this Blackboard-based condition to just abort the underlying behavior as soon as the condition changes.
So we abort
Which means,
self.
yeah, which means like observe this value, and if it changes, you can abort self, which will also like. Okay, so now put the weight, put 360 an hour there, put a big value there, and then start the game.
Okay, save, play.
And now he will be just standing there for 360 seconds before reconsidering. But
but if we do
abort, if you change this to abort both, which means we allow this condition to abort both the underlying nodes as lower priority nodes, then it should just kick in as soon as AI notices you.
Yep, it's running away. I'm still within his perception radius?
No, that's this 360. Just question is why?
Oh.
He's doing the 360 seconds wait.
Yeah, but
which gives us a lot of time to debug why. I would mean.
Okay, so.
I mean, it's visible, true.
So that.
Why doesn't it work?
Is it.
So.
On value change. Does that change the behavior? Yeah, this is how I debug. Push buttons. Huh? Huh?
Yep. But now test him stopping when you just move yourself out of sight. Like make him run and then go back.
Yeah, so we'll just be like.
Oh, damn.
Yeah,
okay, so there's something.
So we jammed him out.
Yeah, something's broken there with this.
Yeah,
that's why having long waits is not a good idea. Having short ones allows AI to recover in such a case. But I'd like this project to debug this.
Sure.
And now put just a second there or something. So because it should work, it should abort both the wait, being able to abort the waiting and movement.
Well, it seems like you almost want to do you want to be able to do on either. I mean, we could, but no, the first one wasn't really doing much for us because the result. I don't even. Perhaps you could explain to me what that really means. Restart only if the result of the evaluated condition has changed. So if this was already false,
because you can have a condition, Blackboard condition checking if you have an enemy.
Okay.
Which means it just checks if an enemy value in the Blackboard is null or not. If it's like set or not set. But sometimes if you have like a lot of possible enemies, you can have an enemy and suddenly have a different enemy, and it's still set, but it's a different value. So that's what it does.
Right.
But I totally agree. Having both would sounds like a good idea as well.
Yes, because we're like
you want to react to anyone touching this. This key.
If this even so much as flickers back and forth, right? Or, well, no, hold on. So this is being set, and then it's never going to be able to come out of this because if we're still set to, if this succeeds, right?
Yeah.
That means this is still set to true. And then we're kicking into the wait. And now it's successfully...
Wait, if you successfully leave this branch...
then we're never resetting...
But you're rerunning the whole tree, because the control goes to the real root, which is the selector, and it
But
finishes.
this will still be true. Because I don't think we handle that.
Well,
like in our...
I'm not sure I know what you mean.
Like in here.
Yeah.
Like, okay, so we come in here, right here. We're setting our bool, successfully sensed.
Yeah.
Right? Is this actually successfully being run when we leave the range? Like if we get out of range, is this being run so that we refire this to set that the false to even change the value so that the Blackboard would force a reset and redrop back in?
So we are calling this function from as a result of handling the perception event as well, right?
Right. So it's coming in here,
so
but
it should be
getting
updated.
Well, no, because our perception update is doing a for loop of all the updated actors. And if we're not being passed into here, we're never going to test true through here. This is never going to refire. We're never going to refire towards false.
Yeah, but if the perception is not being changed, then the information we have in the Blackboard is still valid. We don't have to update it if it didn't change. But if
Well,
it did
okay.
change, we will get that notified.
Here, let's.
I
Where's-
don't say you're wrong. I just
Yeah,
say
it's
I'm
like,
stupid
so-
and I don't understand.
Yeah, right. It's so he's flipping out because we're kind of close, and since we're staying within range, like the values make sense for him, right?
Mhm.
That's really cool. I just noticed the nav mesh stuff down there.
Okay, and now he ran
Okay,
out
hold
of
on,
the
let's
range.
let's jack that value back up so that we can actually have him break, because that's what we need to do. We just need to break him.
Mhm.
So, which looks like he'll break. around the
Any
corner
second
there.
now.
Okay, we've broken him, right? So we're
Yeah.
moving in and out of this,
Yeah, no.
And
Obviously, the perception is not being updated.
right?
Well,
So,
it is. Wait,
well,
it
no, the
does
perception
say-
the perception's
yeah.
being updated, but we're not updating
Can you
that.
Can you without leaving the game? Can you switch over to the Blackboard? Okay, and can you press
enemy-
pause now?
enemy is true.
Okay,
So it's-
and now go back.
okay, back.
Okay, so it did move.
And so we've been doing a ton of movement, right? And so,
Yeah, but it means like the movement finished with success, but somehow it ended up going to wait task still.
right. So,
Just step. Okay, the movement succeeded. Next step.
so then this will succeed. And then we've had a success, so our selector fails. But we can still see us. So we'll find a hiding spot. And then we'll move to that hiding spot. And of
Mhm.
course, we've succeeded.
Yeah.
And then
And so on,
finally,
yeah.
we'll come down to, okay,
Well, something failed. Okay, right.
we
Right. Okay, so it's like it's a border case because
Mhm.
he lost the sight of us, so he stopped,
Mm-hmm.
and then we
Because this should have updated perception,
yeah
but is enemy visible is still set to true, and it's still going to be true. So when we move back and forth in between the perception radius, we're never getting that update for this.
So that might be a side effect of the way behavior trees figure out what to do and when. Because if something finishes, the next task is not being picked this very frame. And if we end up doing an update to the possible conditions in the meantime, it can like fall apart, which is a bug in behavior tree code.
Yep.
Basically.
And that's
So
cool. It's just it's
Give it to
good.
me.
It's good to know. Like, and I mean, we can do like part of game design, right? Like, I would come in here and I would handle false off of here. Just be like, hey, I just need to make sure that I can't see anything, so I'm going to set that value to false, which is really simple because we just come in here, we just copy this bit out, go back into our event graph, drop it in, and if false, we're just going to simply say, hey, we can't see anything, so that's fine. We're setting it to false, and now, hopefully, when he loses perception, he'll just fail. That'll just fail out, and so we can get him to lose us.
yeah,
And then if we come
that's
back
doing
around-
nothing.
Yeah, it doesn't want to do that
It's not doing anything because
because
we have enemy all the time, except for the first couple of ticks, so
Yeah.
it doesn't matter.
it doesn't
really.
matter. All right,
So, like I said, it
we
might
need something to handle it,
might
but
be a
we
core
don't.
AI bug.
Anyway, we should probably take some questions and answers at this point. We have been going now for 1.5
Whoa.
hours.
That was fun. Time flies when you're having
Nothing.
fun.
I know you have a meeting at 4, so
I might have one. Yeah, I'm not sure.
maybe he maybe has a meeting at 4. I mean,
Let me-
there's nothing
let
on
me
after
Grab
us.
my
so
phone.
We'll we have a bunch of questions from the forums, and it looks like we have a few that Alex has posted up for us in
Yeah.
the in our doc here. And so let's go ahead and wow, first one. We're not starting small, are we? How to make an AI that can learn and remember. Skynet.
Where to start? Yeah,
That's the next stream, by the way. We're building Skynet.
yeah. That will be the next AI stream, and that will be the last ever stream for humanity.
Forever.
Forever, the last ever. It's a well. There's nothing. We don't really support it out of the box. Basically, there's a lot of stuff you would need to build yourself. You obviously can use Blackboard to store data. Learning is well defined. There's multiple techniques you might want to use. to implement that from and depends on what you want to learn about. If it's like an evolutionary fitness, then you just use generic algorithms. You can use neural networks and train them on the fly, and good luck with that, because it's it's super hard to get right. Like most of the, actually all, most. I won't say all because I don't know about everything, but most of the real world applications of neural networks are being trained up front, and then on the runtime they just being used, so they don't gain knowledge while being used. They just are already trained. So yeah, they do a lot of AI reading, and it's a huge topic. Like you said, it's kind of, and if people knew how to do it really well,
so much money for those people.
No, we wouldn't have this stream. That would be already Skynet.
Yeah, well, yeah, we'd probably already be at Skynet, because that's the first thing that happens, right?
Yeah,
that's what the media tells us. So yeah, really, really huge question.
Yeah.
So I got one here. Could you tell us how to get? I believe it means EQS, working with multiple player targets online. There's a word "so" here. I'm assuming either EQS or behavior trees. I mean, it's really just instead of choosing from one like we have,
that's basically what we did.
You choose multiple, and you choose the best ones out of
whatever
set you desire.
And you would like to probably implement your specific tests, so that you can tell which enemy is better. Like have some extra testing for enemy range or factions, or like checking online rankings to target the best guys and stuff like that.
Yep.
But basically what we did, and I have a context that just returns the set of enemies instead of just one, the current one.
Let's see. The next question: what does it mean when the face is red instead of green here? So when we're out here.
Yeah. So I don't really remember what it. Okay, I do remember. So it's the green means the AI logic is just running. It's not being paused. You have AI logic pausing or stopping functions on brain component. So if AI logic, like autonomous logic, which is behavior tree, is not running, then the face will be red. If it's green, it means AI just does like the autonomous behavior. Stop showing off our bugs. It's just change. No, change the weight to the weighting.
We'll change the weight back to 1.
Yeah.
So. Where the hell did you Jeez, man, God.
Yeah.
All those bugs, you're just showing them.
Yeah.
All right.
Don't tell people we have bugs. They wouldn't know.
Okay. Can you talk about performance issues with multiple enemies and grid number? I'm assuming, like, if we have like the EQS running here, if we were to have 20 guys and they're all doing the same thing, how do we solve behavior?
Or maybe the question is about like the same query, but we have a lot of enemy contexts. It's like you just have the set of enemies.
Well, both of them hold
Yeah. So
true.
basically, like in all, if we had a lot of AI using the same test, there's no knowledge being shared. So it will be just as expensive as having this same AI running the query 20 times more often. Like if you have 20 AIs. If you have more like multiple enemies, every test is a separate step. So we would have if you have multiple testing visibility for from multiple enemies, we would do the test for each enemy. But with every step we're filtering out items that just failed the test. So with every filtering step, there will be less AI to less enemies to. You can just distract me. I have ADHD, so it's super easy to distract me.
I'm sorry. Jeez, I was just trying to.
So where was I? Yeah, well, it wouldn't be linearly. That it wouldn't scale linearly.
Yeah.
But it will scale. I mean, it will be more expensive the more AI, the more items to test against or context to test against. But not as much as you would fear. So it's like there is some magic happening inside EQS, so that we not do redundant work. If we know this item is not going to pass anyway, we just don't test it anymore. That's the whole idea of EQS. That's why it's like we're doing crazy stuff with it in Fortnite, and it's still like a surprisingly cheap. And it's, by crazy, I mean like really crazy.
Like our test here is very tiny.
Really crazy.
Yeah.
Like crazy.
All right. Next question. The engine registers the message. AI is stuck and cannot move. How can we read that and take action? I have never seen this. Well, I've never seen the message. I've seen the jam occur. Actually,
I'm not sure.
Talking with Alexander, and a guy just kind of got stuck. And he was on the nav mesh.
Okay.
He wasn't jammed into collision. It's just like, I don't know.
I would need to look for it. I mean, this might be related to nav mesh walking, which would mean if you're using, I'm not sure if it was available like just to use before 4.8, maybe. I don't think so. Currently, we have nav mesh walking as a alternative walking mode, which means you can use nav mesh for testing if AI is like on valid geometry instead of just using the actual geometry, which is a lot more expensive. It's something you would like to use for AI that are far away. Fortnite is using it, and only switch to regular movement, which is a lot more expensive when AI is like clearly visible from close distance for player.
Alexander just updated it. It says return for AI move to is enum, or
yeah. So if you use AI move to blueprint node, it gets you a result of the movement, which means like if that's the case, if that's what we're talking about, it might be because AI has been just blocked. If AI is moving somewhere and like in the default config, the default configuration, the player can just stand in front of him and is able to block him. And if the state persists for a couple of seconds, and I think that's configurable somewhere, then AI reports movement failure as blocked, which may be this case. But I would need to look at the code base.
I think Alexander has a project that
cool.
that demonstrates
File
that.
it.
So and it looks like so we have a ton of forum questions. You guys actually
like ask questions on the forum.
Ask all the questions, which is great. So we're going to go ahead and drop into some forum questions. Alexander will keep updating us with questions from chat, and we'll answer as many of these as we can in the next 13 or so minutes.
Yeah, I'll try to be brief, so we will be able to answer a lot of.
Sorry, Alexander, you're part of this. All right, forum questions. I'd like to hear. I'm going to butcher your name again.
How this guy reviews the long-term.
I'd like to hear about this guy's views on long-term AI roadmap for the engine. What features does he intend to work on himself in the near future? What features the community would produce, etc.?
So whatever community is willing to produce, I'm super happy to include that, as long as it doesn't butcher other subsystems, or like makes sense in the whole AI module, because that's where we should be adding things. So whenever you have something or like want to propose something, like just make a pull request on the GitHub, and I'll have a look at it. Regarding the things that are on the list to do, it's actually a really short list. It's pawn actions, and I will just because someone else asked about pawn actions, and I will briefly describe them in a second. It's like wrap this up. The other optional thing is, I'd like to do it, and I know audio guys would be super ecstatic to have it. Is Chatter Manager. It's a little system we had in Bulletstorm that allows it easily to define for AI event-triggered sound cues, so that you can have an AI specifying like a list of events, like sound events it might want to trigger. It's like attacking, hiding, out of ammo, and stuff like that. It's like it's an ID, and then audio guys would be able to specify like this ID means this cue, and this one is that one. And the Chatter Manager was a system that was making sure not too much stuff was being triggered at the same time, and making sure that and every event could have a priority, which helped making sure that, for example, dialogues in the game and stuff like that are not being interrupted by lower priority sound. So if an AI is making a very important comment to the player, for example, he won't say "ouch" in the middle of the sentence, even if you shoot him, because that's important for scripting purposes. So that's on the list, but it's not approved yet. I just know a lot of people would really want to have it, and that would be the last big thing, like a last new feature we would work on. And from that point on, it's basically working on stabilizing everything, and the performance, and blueprint interfaces and usability. Because we gained a lot of ground last 2 years, started implementing a lot of stuff. It's all really nice and usable, but there's a lot of bugs. It's usually the border cases. Most of the people won't hit those bugs, but with thousands of people using our engine, it's like every one of those cases is getting hit. So that's my point of honor to handle all those things. And the pawn actions, like I'm saying pawn actions, but pawn actions was a prototype of an idea that Fortnite is using a lot. And basically, it's an action is pawn action is an action that is visible to the player. You can trigger on a pawn. And it can be triggered both from behavior trees and like gameplay code, which means like hit reaction stuff, and also would be able to be triggered from level scripting, which means you could hard script AI. You go here, then play this animation, then go here, and then die, stuff like that. Like really old school hard scripting. Currently, it has been used for Fortnite by Fortnite for a while now. And there are other companies that are using it as well because it just comes with the engine. But now I'm in the process of implementing a proper way of doing that, which will be generic enough. It will be the name is gameplay tasks. If someone heard about the gameplay abilities that we have in the engine, it's like really good, powerful feature we have, but it's not documented because it's like you can use it if you want, but at your own risk. I mean, we have 2 projects that are using it and it works. It's just we don't have time to properly implement the documentation for it, and so that like people know how to use it. So gameplay abilities will be using gameplay tasks as well to make AI do stuff from within the ability. And that's what I'm currently working on. So gameplay tasks equals pawn actions from AI point of view.
Okay, so a lot of these.
So if I'm not able to answer some of these questions, I might not be there.
Yeah.
I will answer them on the thread where they were asked.
Yeah,
I'll just do it.
There was one in here about the one we hit the AI perception debug stuff. So
yeah, we showed that.
That was pretty awesome. There was another one here about the dynamically generating large world.
Yeah. So that's the navigation invokers. I've recorded an internal use video recently. You've seen it?
Yep.
Yeah. So there is a nice feature. I'll talk to someone to record a proper version of it.
We can get Wes or me or Zach.
Because it's really easy to use. I mean, pretty easy. You set
it's a bunch of settings.
It's a bunch of settings, but you do it only once,
Yeah.
and then magic. It just works. But it just boils down to like you have navmesh support on like huge map, but you specify navmesh invokers, which are the actors telling the navigation system. But I just need navmesh. I just really need navmesh in this radius around me, and it just takes care of that and makes sure it all works nicely, and you don't have hitches regarding that, and you still have regular navmesh walking and pathfinding. It just works. You can have like this radius can be really big. You have a lot of navmesh information, and it's still pretty cheap, and you can save on huge maps. So on the kite demo map, we saved like 10 gigs of RAM. So that would be 11 gigs if we wanted to have like the naive implementation, the whole map. And in the kite map, it takes like 500 megabytes now. So
that's not bad at all. And there's a lot of deer out there.
Yeah, and they just work.
Yeah,
the deers are navigation invokers basically.
Yeah.
So they just tell navigation system, I need navmesh around me. But when we stream the deer out, the navmesh just disappears there and doesn't take up memory.
Right.
So it's awesome.
Yeah, and there was also some questions about the deer, and we'll see if we can find the person who
That
actually
did that, yeah.
who did that to answer those questions for you guys, because those were really, really awesome. Let's see. Depending on
I have those red
think-
spots here. Like
yeah,
he
think
has
we-
been hitting me.
yeah,
we were
right.
out of
I've been
sight.
hitting him, right?
Now it's just blood rushing to my head
Yeah.
because I really love this stuff and I want to like
Just
pour the knowledge on you.
All right, and it doesn't look like we have any other additional questions. Everything, like,
Some of the stuff people were asking about are already available in 4.8.
Yeah.
For example, the navigation invokers, that's a regular feature.
and also
4.8.
the blueprint ability to call EQS.
Yeah. There's
That's
a
in
blueprint function that allows you to call a EQS query,
Okay.
and you get back a
Yep.
kind of a query instance that will allow you to just get the result at some point. Because one thing to remember is EQS queries don't run instantly. You just get an item and you need
Yes.
to bind an event on it so that you get notified when it's done. But
That's really cool. You can set the query and
that looks like yet another tutorial.
yeah, right. Because if these are delayed, that could end up rather interesting.
Yeah, it turns out I do have a meeting at 4.
All right, well then we'll go ahead and wrap this up. If there's anything that we didn't get to, guys, we're gonna try to get it posted up on the forums. And I believe I don't think I'm back next time, and I'm not back in 4 weeks. I think that's gonna be Alan Noon. I'm not sure who's up next week for this, but as we get more AI stuff in, we'll come up back on here, and maybe one of these times we can actually dial you in instead of. No, wait, it's gonna be like.
Yeah, we could give it a try. I mean, have
How
you
early in the morning would
done
that
that?
be for you?
It's not that early. It's just 6 hours. So now it's.
Oh, it's only 6 hours? So it's like,
no,
it's almost 10
I
your
can't
time?
count.
Yeah, it's almost 10 your time?
Yeah, it's just
Alright.
we could do it earlier, or
Yeah.
but yeah, I just wonder what would be the quality of the connection. That's the biggest problem.
It's pretty good?
Have you did
Yeah,
that already?
yeah.
Okay, cool.
We've done it before, so.
Awesome. Okay, yeah, sure.
So
Count me in.
we'll get you in.
No problem.
All right. Well, thanks, guys, and we'll talk to you later.
Okay, see ya.